Welcome back. Today we're going to look at basically using some of the trigonometry stuff that we've done of late. So we're going to look at how to use sine law and cosine law and also, practice making use of our triangle decision tree. So we're going to just kind of revisit some of the stuff that we've done so far. So, our revisit of trig and practice using our decision tree. So what I'd like you to do, of course, is anytime I put a problem up here, I'd like you to copy the problem down, pause the video, and give it a whirl. So I'm going to draw up a triangle here, and I'd like you to solve it. Okay, and so when I say solve a triangle, what it means is that you have to try and find all of the unknowns of that particular triangle. So if we start out with this one, so imagine that we had this side here was, I don't know, how about we make this 8 meters, and this side here is going to be 6 meters, and I'm going to tell you that this is 50 degrees. And so I'm going to say solve the triangle. So that means solve for all of the unknowns. Normally I wouldn't do this, but I'm going to assign some variables. So I'd like you to solve for x, y, and z. But know that, of course, when I say solve the triangle, what it really means is to find all of the unknowns. Okay, so go ahead, pause the video, and then come on back. Welcome back. So we're going to look at our triangle decision tree. So the first thing in our triangle decision tree says, if we know 2 angles, solve for the third. Well, we only know 1 angle, so we're not going to solve for the third here. Then the triangle decision tree says, is it a right triangle? And I mean, in theory, it might be. This might be a right angle here. This one doesn't look like it's going to be a right angle, but they're not always drawn to scale. But if we don't know that it's a right angle, we have to assume that it's not a right angle. So that rules out Pythagorean theorem, and that rules out SOHCAHTOA. So we can't use those. So then the next thing that we need to do is we keep going down our triangle decision tree, and we say, oh, do we have a known angle opposite a known side? And if we look right here, this is what we've got. There's a known angle opposite a known side. So what that means is we can use the sine law. So we're going to set up the sine law. Now we're looking for both angles and side lengths. So how do we decide which version of the sine law we're going to use? Well, you can just choose one. So I'm going to go with the A over sine A equals B over sine B equals C over the sine of C. And then I'm going to probably assign some letters over here just to make my life a little bit easier. So A, B, and C, which means this is little a, this is little b, and this is little c. So little a is going to be 6 over the sine of y. And little b is z, and that's going to be over the sine of x. And it's equal to little c, which is 8. And that is over the sine of 50. Now, we filled it all out. When we're done, we have to think about, what is it we have to have here? Well, one of the things we have to have is we have to have a complete ratio. Well, we've got a complete ratio, that one right there. Okay, so that bodes well. The other thing we have to have is a half complete ratio. This is not a half complete ratio, so I can't use it. However, this one is a half complete ratio, right? So there's my half complete ratio. So that means I'm going to have to use these 2 ratios in order to move forward. Now, obviously, that means I'm going to have to, I can't solve for z right off the bat, right? This is a fully incomplete ratio. I can't use it yet. I'm going to have to solve for y. Now, I like to have what I'm looking for on top. So I could solve it. So maybe what I'm going to do is I'm going to show you 2 different ways that you can solve it. The first way, so method 1. Method 1 is how I would definitely do this. And this is first thing we're going to do is we're going to use these 2 ratios. So I can rewrite them side by side. So we're going to have 6 over the sine of y equals 8 over the sine of 50. Now, I don't like what I'm looking for to be in the denominator. And so we talked about the idea that sine ratio could be written either way. So very next step I'm going to do is I'm going to just flip both of these. So I'm going to say sine y over 6 is equal to the sine of 50 over 8. Okay, so that's better because now what I'm looking for is in the numerator. Now I need to solve. So it's being divided by 6. So the opposite operation is multiplication by 6. You're going to multiply both sides by 6. Those guys are going to go away. And then we're going to have that the sine of y is equal to all of this. Now, you could take and put that into your calculator. You could do that. It would be better if we didn't do it, if we did it all in one go. So I'm just going to rewrite it. So I'm going to say the sine of 50 over 8 times 6. Okay, that's what we're going to have. Now, y is being signed. The opposite operation of sine is sine inverse. So I'm going to sine inverse both sides. So sine inverse both of those sides. Those signs are going to go away. And on the left-hand side, I'm left with just y, which is awesome because that's the variable I'm looking for. And on the right-hand side, it's this when I type it into my calculator. So again, you have to, be comfortable with your own calculator, making sure, of course, remind again that the mode it needs to be in is in degrees. My calculator always defaults to radians, but your calculators at home should just kind of stay the same as always. So I'm going to do sine inverse. On my calculator, puts a bracket there, which is good. I've got a bracket of the sine of 50 divided by 8 times 6. Okay, I'm going to put that in. We're going to find out that it is 35.07 degrees. So I'm going to come back here and say it is 35.07 degrees. And there it is. That's why. So that's the first method. That's the method that I would prefer that you did, but it's not the only method. So the second choice would be, starts out the exact same way, and it's nearly the same, just subtly different. So method 2, so I'm going to rewrite these again. So we're going to have 6 over the sine of y is equal to 8 over the sine of 50. Now, instead of flipping it and then clearing everything out, what we can do is we can, right off the bat, I'm going to grab a different color pen here. We can cross multiply. So I'm going to multiply the sine y up that direction and the sine 50 up that direction. So we're going to have 6 times the sine of 50 is equal to 8 times the sine of y. Okay, now we want to get the y all by itself. So what I'm going to do is say, all right, sine of y is being multiplied by 8. Opposite operation is division by 8. Divide by 8. Those go away, and on the right-hand side we have just the sine of y, and on the left-hand side we have 6 times the sine of 50 over 8, which if you look up here, right here, I guess, it is the exact same. So all it did was it just took an extra single step. So now I'm just going to sine inverse both sides, right? So I'm going to sine inverse the left, sine inverse the right. So sine inverse and sine inverse. And those ones are going to go away, and we're going to have just y equals, and then I can type that into my calculator. Well, it's the exact same thing as what I typed in over here. So it's going to end up being 35.07 degrees. Okay. So what's cool about that is it doesn't matter which one you choose. I just really like what I'm looking for to be in the numerator. So that's why I would prefer this method. Okay. So we go back. 35.07 is what y is. So I can go back here and I can say, all right, you are 35.07 degrees. Now we kind of start the process over again. I know it's not a right triangle, or I mean, I guess I don't, but what I do know is I know 2 of these angles in the triangle, so I can figure out what the third angle is, because we know the angles in a triangle have to add up to 180 degrees. So I can do 180 minus these 2 things to find out what x is. So I'm going to say, all right, that means that x is equal to 180 minus 50 minus 35.07 degrees. Okay, and so I'm just going to grab my calculator and I'm going to punch that all in. So we're going to do 180 minus 50 minus 35.07. We're going to punch that in. We're going to get 94.93 degrees. So go back up here and say, all right, x is equal to 94.93 degrees. And why that's useful is, well, we know it can actually go in right there. So to finish off and to solve for z, because now we've got, we have y, we now have x, all we have left is z, is we're going to, again, use this ratio, right? Because this one is the original complete. We're always going to want to work with the one that's where the values that were given to us. It's always better to use the given values than ones that we have found, because if we make a mistake, then everything else is going to go wrong. So this is what x is. So I'm going to write this, and it's going to be z over the sine of x, but I know what x is. It's 94.93 degrees. So the sine of 94.93 degrees is equal to 8 over the sine of 50 degrees. So all good. So the only thing we need to do now is z is being divided by the sine of 94.93. So I'm going to multiply both sides by the sine of 94.93. So I'm going to multiply by the sine of 94.93. And I'm going to multiply by the sine of 94.93. And those are going to go away. And z is simply going to be whatever this is when I type it into my calculator. So I can grab my calculator. Here we go. So we're going to have 8 divided by the sine of 50 times the sine of 94.93. Then we're going to find out that that side length is 10.40. So 10.40, or not degrees. Let's get rid of that. So hang on. Undo there. So 10.43 or 10.40 and whatever it was, meters. And there we go. So we have just solved that triangle. So as a reminder, when I say solve a triangle, what I want you to do is I want you to find all of the unknowns. Okay? So that's awesome. So let's try another one of those. So let me just grab whatever color this is. Where are we at? Oh, okay. So let's try another one. So if we had the following triangle. There we go. Imagine that we had all of the sides. Imagine that we knew that this side was 8 meters, this side was 7 meters, and this side looks to be maybe 12 meters. And I said, go ahead and solve the triangle, right? So there it is. Go ahead, solve the triangle. Okay, if you are back because you need a hint, I'm going to give you a hint. Obviously, we have 3 angles that we're looking for. So I'm going to put an x, a y, and a z in here as the unknowns that I'm solving for. Now, think about your triangle decision tree. Do we know 2 angles? Well, we don't know any angles, so we don't know 2 angles. Is it a right triangle? Well, who knows, because I don't know any angles. Do we have a known angle opposite a known side? Well, we don't know any angles. So that means that we're left with cosine law. So with that hint, maybe that's enough to get you going. So if that was enough to get you going, go ahead and pause it now and give it a whirl. Okay, now we have a decision tree or a cookbook recipe, as it were, for cosine law. So for cosine law, what we need to do is, it's not like sine law. Sine law, you can put the letters wherever you want. Cosine law, that's not the case. Cosine law goes, the first thing is you have to put C on the angle you know or you want to know. Now, you could put C on any one of these corners because we need to know all 3 of those angles. So you could put it anywhere. My suggestion to you, it's based in a reason that I'm not going to bother explaining, but it's as a general rule, you should put C on the largest angle if you don't know any of the angles. So I'm going to put C here, which means that A and B can go in either spot, right? So A and B. So this is going to be my little A, this is going to be my little B, and this is going to be my little C. And then so cosine law is C squared equals A squared plus B squared minus 2AB cosine of uppercase C. So little c is, well, that's 12 squared. Little a is 7 squared. Little b is 8 squared minus 2 times 7 times 8 times the cosine of, well, uppercase C is actually this y value. So that's what we've got, which is great because we've only got one variable left. Now, finding an unknown angle with cosine law is probably the most challenging of any of the trig functions that we have to do. We have to be really, really careful. So what I would suggest is I would simplify each of these numbers, right? So simplify this guy, simplify this guy, simplify this guy, and this is all one number because it's a product. So simplify that. So I'm going to do that. So we're going to have 144 is equal to 49 plus 64 minus, well, that's 56 times 2, so 112. So minus 112 cosine of y. Lovely. Now, this is where students often make mistakes. Some of you think that you can take the 49 and the 64 and subtract off the 112. Can't do that. Don't be that kid. Okay, this is being multiplied by the cosine of y. So this is a constant term, this is a constant term, but this is a coefficient on a variable term. So we can't put those together. They're not like terms. So first thing I'm going to do is I'm going to lob these two to the other side, and they're going to become subtraction. So we're going to have 144 minus 49 minus 64 is equal to negative 112 cos y. And yeah, it's negative, right? This negative here belongs to the 112. So it didn't go anywhere, so it's still negative. So I'm going to grab my calculator and I'm going to simplify that. So we're going to have 144 minus 49 minus 64 is equal to 31. So the left-hand side, we've got that 31 is equal to negative 112 cosine of y. All right, we're closer. I want to get the y all by itself. This negative 112 is multiplying the cos y. So I'm going to divide both sides by negative 112. Divide by negative 112. It's worth pointing out that this number that I simplified over here, this 31, doesn't always have to be positive. Sometimes it's negative. And that's okay. It doesn't, like if you get a negative here, you might think, oh, I've made a mistake and get rid of it. Don't, because it's a distinct possibility that negative is the right answer. Okay, so these negative 112s are going to go away. So we're left with the cosine of y equals 31 over negative 112. Closer, I want to get y all by itself. So right now, y is being cosigned. Opposite operation of cosine is cos inverse. So I kind of think I'm going to pop that over. It's not what happens, but it's going to be on the next line, the cos inverse of 31 over negative 112. What we really did is we cos inverse both sides. So I'm going to show that, cos inverse of the cosine of y. So those are going to go away. They're inverse operations, and I'm left with y equals. So I'm going to grab my calculator here, and we're going to do cos inverse of, now mine already puts a bracket there. If it doesn't, you need to do that. 31 divided by negative 112. Okay, we punch that in. And we're going to get 106.07 degrees. Okay, so 106.07 degrees. And so that is angle Y. So we know that this guy up here is 106.07 degrees. Lovely. We have one of the angles. Now, this is where it gets interesting, and it's up to you to decide how you want to do it going forward from here. If we were to go through, like if I gave you this triangle the way it is now, including this 106.07 degrees, and you went through the triangle decision tree again, what you would find this time, of course, is that we actually have a known angle opposite a known side. So that means we could use sine law, okay? And I figure that's actually the most efficient, okay? So I'm going to jump into sine law. But what you could really do if you wanted to, if you're like, oh, you know what, I kind of like this cosine law thing, you could do that. You could come back here and you could leave that 106 the way it was, and then just rewrite where these letters go. If you wanted to find this angle next, you'd say, oh, well, I'm going to put my C here, and then repeat all the steps of the cosine law, and that would totally get you this angle Z. Or you could put the C over here and get this angle X. That would absolutely work as well. But it's a lot more work than using the sine law. So I'm going to go sine law now. And so I'm going to use sine law to find angles. So I'm going to say, oh, that means it's the sine of A over A equals the sine of B over B equals the sine of C over C. So I'm going to fill those things in. A is Z. So I'm going to have the sine of Z over A is equal to the sine of B. Well, B is X, so the sine of X over 8 is equal to the sine of C. Well, we know that initially C was Y, but now C is 106.07. So it's going to be the sine of 106.07, okay, over 12. So we're in decent shape. What we've got now is we have a complete ratio. Yeah, it's using a number that you weren't given, but in this case, we don't have a choice. This is just how it has to be. And then we need a half complete ratio. So, oh, I could have put a 7 over here. So let me erase that and just correct that. Okay, you guys probably spotted that. There we go. So we get rid of that. So this is actually a 7. So this is a half complete ratio, and this is a half complete ratio. It's entirely at your discretion which one you solve for next. I'm going to solve for the x simply because it's right next door. So I'm going to rewrite it. So we're going to have the sine of x over 8 is equal to the sine of 106.07 over 12. Okay, so I'm going to go ahead and solve. Sine x is being divided by 8. Opposite operation is, of course, multiplication by 8. Multiply by 8. Multiply by 8. Those guys are going to go away. And so then we're going to have that the sine of x is equal to the sine of 106.07 over 12 times 8. Okay. Most of the way there. Right now, x is just being signed. So the opposite operation of the sine of x is the sine inverse of x. So we're going to do that. So we're going to have that x is equal to the sine inverse of all of this stuff. So the sine of 106.07 divided by 12 all times 8. And I'm going to grab my calculator and I'm going to type that in. So we're going to have that x is equal to the sine inverse of bracket, the sine of bracket 106.07, close that bracket off, divide by 12, times 8, close that bracket off. And we're going to end up with 39.84 degrees. So we have found that x is equal to 39.84 degrees. Okay, my clock is saying hello. So that has got us now with 2 of the 3 angles. So 39 point, what was it, 84, I think? 84 degrees. Okay, 84 degrees. So now to solve for z, all I need to do is 180 minus those 2 angles. So I'm going to grab that, and we're going to have 180. Doesn't like doing like that. So 180 minus 39.84 minus 106.07, 106.07. And what we're going to get is 34.09 degrees for this one. So this is 34.09 degrees. Okay, and there we go. We have solved that triangle. Okay, so that's it for this one. I'm going to put up some homework questions for you to try. And then tomorrow I'm going to put up a video. The next 2 days after that, we're going to have videos of how to use these in problem solving. And then I'm also going to give you on Wednesday an assignment that I'm going to let you work on, and it's going to form most of your work for the next week as well, when it will take place as opposed to having a test in this class. Okay, thanks for joining me, and another lesson will be up tomorrow. Thanks, guys.